quick bit of background only for a few minutes ourselves and the company, and then we'll just jump right in. So as I mentioned, I'm Ali. I'm one of the co-founders. Prior to this, I founded a couple of companies. Previous to this, I was at a company called StackRox. We focused on infrastructure and Kubernetes. Before that, a company named Cyfort that was focused more on endpoint security and disk response. My whole career has been really a combination of data, privacy, and security. So it was only natural to come to Gretel. The best part of it is I get to work with two of my really great friends from a very long time. So Alex and John. So I'll turn over to you guys. Alex, John, you want to do a quick background and we'll jump in?
Sure. Hey, I'm Alex Watson. I lead our applied science and product development teams. And very similar background, as you'll see, to Ali and John. So started out in the intelligence community as well. This is my third startup. And previously, my last startup was a company called Harvest.ai. We were helping companies identify and protect data inside the cloud with SaaS applications like Google Suite, Office 365. We were acquired by AWS, and we built and launched the first couple of security services for AWS. A lot of that experience kind of led to where we are with Gretel, this idea of making data more accessible, more visible, and kind of breaking down that competitive barrier that some large companies with tremendous amounts of data have that really give them a data advantage.
Hey, I'm John, one of the founders here, and I run our engineering teams at Gretel. Prior to Gretel, I had a cybersecurity startup, and similar to Ali and Alex, I have a background in cybersecurity from military and the intelligence community. At my previous startup, we collected massive amounts of data from computer networks and endpoint systems and analyzed it for various threats. I pivoted into privacy engineering once my previous startup got acquired, and we were looking to build products on top of data, as a lot of companies are, and realized that there was not a lot of tooling out there to help automate anonymization of data or help create usable data sets that are free of privacy risk. So had to build a lot of those tools myself. When I teamed up with Alex and Ali, we realized that we could try to boil privacy down to an engineering problem and set off to build Gretel that attempts to build or provides tooling and APIs for developers to more easily work privacy engineering into their everyday lives.
All right, so we'll jump in and give you a sort of a quick background of how we got here with Gretel and why the community side of it is so important for us. Really, the community plays a massive component of what goes into our product roadmap, components that go into our open source projects, and really how we think about building for the future, because really our target audience are builders, developers, scientists like you. And what we're trying to do is build sort of best-in-class toolkits for data. And what we're trying to do is build tools that make it easier, faster, and safer to work with data. At the end of the day, what we want to do is make data safe so everyone can build with it and remove a lot of those barriers. The other part of it that we found is very important is to making sure that working with data is also easy. Typically, it's been very complicated or sometimes frustrating to work with data. So that's another area that we are very heavily focused on. And the right way for us to approach this is to be very inclusive and engage with our community. And this is where we would love questions, feedback, comments, or engagement with our open source or community, because this is how we got here. So to give everyone some sort of context and background, at Gretel, we're focused on safe data. And safe data to us means a toolkit that developers and scientists and builders can leverage to build their own tools, to build their own workflows and ecosystems. We're not opinionated about how you build, only that you build with safety and privacy in mind. And that's really what we bake into our tools. The company was founded in late 2019. But majority of the time that we have been out there, we've actually been in a private and open beta with the whole community. We actually, even though we were founded late 2019, in September of 2020, we opened up our first beta to the public. And the community was tremendously valuable for us to shape the product roadmap and what we ended up building. And three core pillars of our product are data labeling and classification, data transformations, and then really the core where we focus a lot of our energy on is synthetics data, whether it's tabular, time series, and now the work that we're doing in image data. And since then, we've had over 5,000 organic users on our platform. We've had 75,000 plus downloads of our SDKs. And we've been engaged with 60, 70 plus enterprises. And this is really where a lot of the individual users have been paramount into the types of workflows, integrations we built. And some of these we'll talk about, for example, the things we've done to make it easier to work with data, like one-button integrations into S3 or Apache Airflow, and a lot more work we're doing. So these are the areas we would love to hear from you on. What are the areas that we should focus on building our tooling? The way we think about ourselves is not this sort of end-to-end platform you should use, but these sort of specialty tools that help you build workflows and work more easily with data. We launched our GA product roughly about 2 months ago. So we've been out there now for a little while and getting a lot of good feedback and responses from the community. And the community part, as we mentioned, is going to be quite vital for our roadmap going forward. We're actually thinking a lot about what are the tools and pieces that we should be building to make integrations into other toolkits easier. At this time, I'll turn over to Alex and John to touch a little bit more about what we're doing and sort of the work we're doing around the community, and then we'll jump right into the questions and some of the inbound we've had.
So maybe I'll touch on some of the stuff we've done from a product level first, and kind of our whole go-to-market that I think is largely responsible for where we are, 2 years into building the company. We started with this idea of, privacy shouldn't be a blocker to data, it should be an enabler. And can we use synthetic data? Can we use like really awesome privacy enhancing technologies to shorten that period of time that it takes you to share data with across your team, or create a pre-production version of your database, or anything like that, even publish data outside of your business. And it started for us with a couple open source examples and some blogs on Medium and towards data science that we just put out there based on some conversations we'd had with some customers, showing, I think our first example was showing that it was possible to create a synthetic version of like precise location data. Normally it's very identifying, and look what you write on front of someone's doorstep, or anything like that. And here we showed that you could create another data set that had the same types of insights and patterns in it as the original data. What was fascinating on this one was, while we have lots of discussions with big businesses and cloud native companies that are building at high speed, the community has been such a strong signal for us. So response that we've gotten on our blogs and our open source code, the auditing that we have that's possible when you have kind of an open source core like we do, to evaluate, did we implement differential privacy correctly, and things like that has been really neat. And what that's done is that's allowed us to like iterate really quickly. We can put ideas out, we can put out pain points that we hear from customers, and we can say like, we can gauge, from the community feedback, and a lot of people on the, that I see on the list right now, like using that feedback to figure out like, how does this pattern apply to the larger community, and really figuring out what efforts we should dive in on. We've started really working with tabular data. I think that's kind of where we built our first couple examples. So whether it's a data warehouse or a relational database, or really anything in between, structured and loosely structured data, that's where we got started. From there, it's evolved quite a bit, from free text data, which started with doctor's notes inside of EHR things, to highly complex conventional data. We just did a case study with a gene sequencing company here in San Diego called Illumina, which is the biggest genomics company in the world, where we proved the ability to create a synthetic version of genomic data, which has to be like the most complex data you could ever, that I've ever come across personally. So really, kind of neat examples for where we're going next and what we're thinking about, and areas that we're looking for feedback from the community on. Streamlining, I think, continuing to make it easy to get started with synthetic data. For many people, you mentioned synthetic data and you mentioned privacy, and it's scary enough. You're like, oh, it's going to take me weeks to learn it. So one of the things that we started out saying early is like, how can we streamline that point from you deciding synthetic data might make sense for your use case? Like maybe I'm trying to share a version of a sensitive data set, or maybe I only have a couple of records or a couple examples of something, but I need to create more to train my machine learning algorithm. So how do we go from that initial idea to actual value creation? We built console workflows, so you can do everything inside of the user interface. And then also we're trying constantly to make our SDKs, APIs, and things like that as simple as possible. So that's a big theme for us, and other themes outside of there.
Alex, while you're on that topic, actually, there's a question on how does differential privacy exactly help protect synthetic data?
Mm-hmm. Great. So our approach to synthetic data uses, at the core, uses a neural network. And that neural network essentially learns whatever data set that you give it as if it's a language. And what it learns to do is to recreate that language, and you have some ability to influence what type of records that model creates. So really like exciting approach, and then it generalizes the different data sets really well. one of the scary things about neural networks is there's very little way to guarantee what they learn. And one of the risks that we've seen in the synthetic data space, we've seen in general machine learning, is the propensity of models to memorize specific parts of the data and replay it. For many of our customers, synthetic data, like privacy, is one of the core features that it brings out. Like, you don't want it to recreate an individual record or something like that is based on a real human. You want it to create something that's based on everything that's learned across the data set. What differential privacy allows us to do is, during the model training process, we have the ability to insert noise into the optimizer and also clip the gradients. And like, what does that mean? It means that we can take a really kind of strong and mathematically guaranteed approach to make sure the model doesn't memorize data in the secrets or things like that in the data that it shouldn't memorize. So extremely powerful tool. Some of the pros and cons of differential privacy, and it's a fascinating topic, it's worth its own discussion right here, is that it both, in theory, gives you mathematical guarantees about known attacks on data. So, re-identifying data or linking it to another data set that might exist, but also future attacks. So really fascinating in that it's kind of a formal method to guarantee privacy. The downsides of synthetic data are that it often requires a very large amount of data to work well. So where we've seen differential privacy be applied in our lives are, for example, the US Census data, or Google and Apple use it on their iPhone and Android operating systems to kind of predict the next text token that you're going to type into your screen. But all of that relies on a lot of data. So we see with our customers looking for this balance between like accuracy of the data. So how well does it recreate the insights from the original data set, and privacy? And one of the goals that we spend a lot of time on is helping people find the right balance between those two.
Alex, there's a follow-up question that's on the similar veins, and John, I'll turn over to you after. Actually, you guys can, either one of you can take this, but there's a question that says, I was curious if there's been any exploratory efforts in using GANTs to generate synthetics rather than RNNs, which I believe is Gretel's use. So I think it's worth actually touching on the work that we're doing on both these areas.
Yeah. We believe there is no single bullet for creating great synthetic data, period. And GANs have a lot of advantages. So we started with language models. Our core, as it was mentioned there, Gretel Synthetics package uses a LSTM, a language model currently. In the very short future, we'll be adding support for GANs and even more advanced language models. So we've seen this. I'll link to some blogs that we've posted recently, actually using a GAN for creating image synthetic data to this. So all are fascinating technologies. Each one, anyone that's kind of worked with GANs knows that there's certain types of data that it works really well on. Highly dimensional data sets works well. It's very efficient versus language models at that point too. But you also run the risk of mode collapse. So one of the ones that's really important to us is making sure when people give synthetic data, we give you high quality results that work every time. GANs can be notoriously finicky and hard to configure to work for like arbitrary data sets people upload. So, long way of saying that our answer is that yes to all of the above, that, both language models, GANs, and even, up and coming brand new models and technologies are very interesting.
John, you wanted to add something? There was also a question now about how Gretel works with S3 buckets. I don't know if you want to take that one.
Yeah, I can take that one. So, one of the biggest efforts for this year as we go to market is how we can take the core capabilities of Gretel and start to connect them into various ecosystems. Since S3 is such an underpinning for a lot of different technologies, we recently just released the first beta version of our S3 connector. It's integrated with our Gretel CLI, and you can visit our documentation site to see how to get that up and running. That allows you to currently set up Gretel transform and classification jobs for data inside of an S3 bucket, and then that will automatically pull any object inside that S3 bucket, process it, and apply the various transforms to it, and then write those results back into a secondary S3 bucket. So that allows you to integrate Gretel into a data pipeline, and then anything that can plug into S3, whether it's a streaming technology like Kinesis or a data warehouse, you'll be able to leverage the S3 connector for all those.
Yeah, and there's actually another question sort of along the same lines, which it's asking, what is the difference between classification, transformations, and synthetics? I'll take a swipe at this and then turn over to Alex and John as well. But, first and foremost, the way we thought about this was that, what are sort of what are best-in-class tools that are required for data to be usable and at the end of the day, highly applicable when it comes to privacy requirements? So the difference there is that each of them really do serve a purpose. Classification is really for labeling and classification of data in itself. So understanding what sensitive or PII data is actually packed in your data itself, whether it's structured or unstructured. So we see classification as just a good point of hygiene in your overall pipeline. The reason we include this is not necessarily because this is something we want to heavily focus on, but we do think if somebody wants to get started with transformations or synthetics, having a component where classifiers are available to you is very important. So we want to be able to provide a comprehensive toolkit. Transformations and synthetics have a sort of a unique difference, which is that transformations are more about anonymization, encryption, or tokenization. So they're still reversible. You can still sort of conduct attacks on them to be able to deduce who the original users were behind them, or particular indicators from the source of the data. Where if you're actually using synthetic data combined with things like differential privacy or some of the more advanced privacy filters, then you can get to a point where you have to sort of balance the quality of the data versus privacy, but you can get to a point where you actually have mathematically provable privacy, where none of those original indicators or insights from the data is maintained in the synthetic data. So maybe a sort of an overly simplistic way to explain this, and I would actually love to hear John and Alex on this, is that I think of transformations as only for your team or inside your trusted source of company. Synthetics is something you can actually open up to the world, collaborate, sort of publish on the web, and do sort of more large scale learning or sharing on top of it. But Alex, John, I think that's a pretty important question as to where classification, transformations, and synthetics have the right piece in the overall workflows.
John, you want to take that?
Yeah, sure. So yeah, I think it was a good recap, Ali. To dive a level deeper on the transforms, some adjacent use cases to using transform would be when you already know you have a specific type of policy that you need to apply to a data set, and that policy might be defined by some external party. So you might know that there's certain elements inside of your data set already, whether it's like customer information like emails or phone numbers. And if you know that you have a gating factor and a hard requirement that says like, I know I can ship this data somewhere else as long as I mitigate those direct PII risks, then transforms is a good option because it allows you to preserve all the other factors that are in the data. And then you can also get started a lot faster because transforms is basically a one-to-one mapping to a source record. So for any given source record, we analyze the policy against it, and then we kick out another record. Another good thing about transforms is if your data changes rapidly over time, let's say the underlying like statistical properties of the data changes over time, or you're adding new data elements, you can define those policies to capture those changes in the data and make sure that they're transformed before you ship them. With synthetics, what you often need to do is to capture kind of the changing statistics in the data is to either retrain or extend an existing model to do that, which could be comprehensive. So if, again, like Ali mentioned, if your use case is heavily revolved around like shipping data internally, one example we have from customers is, they basically want to clone a copy of a relational database. So their developers have data that they can use for development purposes. And there's a much, we have to maintain all the relationships in that data between all the different tables. Transforms are a really good option there. Because it'll help you preserve a lot of those relationships with like higher level certainty, especially if there's really tight constraints on the data, which you often see inside of these SQL databases.
Yeah, awesome recap. Maybe to add one thing on there too, I think, and this is—
Alex, just one question for you to think about as you're sort of finishing that is there's a follow-up, which is then how do you assess the quality of synthetic data versus original and then balance quality versus privacy?
Yeah. Wow. Good question. Okay. So I will touch on the first one first. Often, and I think when we see large customers deploying synthetics where privacy is a concern, we see transforms as a pre-processing step. And what you can do is with transforms, you can create a simple policy that says like, anytime I see a customer ID inside, a data set that might be used to train a machine learning algorithm, or we're going to train our synthetic model on, I want to encrypt it, or I want to replace it with something else. So really for removing the known knowns from your data, whether they're names and addresses and things like that, you can have classification and data transforms and synthetics all work together. First, remove or replace, known identifiers inside your data, train a synthetic model on it and generate unlimited amounts of data, kind of matching whatever shape or distribution you're looking for. And it's a pretty cool pattern. And kind of speaking about the roadmap too, while they're different APIs, often they're calling each other. So I think there's a world in the future where this pre-processing step that you're using with transforms, could just be a pre-processing automated step for synthetics. Moving on to that second question of how do we assess the accuracy of the data that we're working with, and the privacy and the balance between those two. This is so important. From the moment we created our first model, that was the first question we had. We're like, wow, it looks great. And you look at the output of the model and you're like, yeah, it looks just like the original source data set, but how well did it capture the insights of that data? How deep did the correlations go? And what is my, kind of privacy stance on this data? We've had some awesome research on our team. So, of our, roughly 35 people in the company, say 6 right now are full-time applied scientists. And this has been one of the biggest research topics we've had, is how do we quantify the accuracy and the privacy benefits that you get with synthetic data? So really what we do, and the approach we've taken so far, is meant to be simple and scalable. So when you generate your first synthetic model, we generate a sample data set. We take the real world data set it's trained on and the synthetic data set, and really from a data science perspective, just kind of throw the kitchen sink at it. We look at correlations in between variables. We look at the PCA distribution across everything. Really, it's meant to give you this like holistic view that you can dive in on to whatever level of detail you want on like how good of a job did the model do at learning this data set. And then it summarizes those into really kind of 2 core stats. One is the synthetic quality score. So it's a 0 through 100 score. Each one of those ratings that you get is mapped to a particular use case. So we say an excellent score, I believe, is 85 or higher. And in that case, what we're saying is we would expect, if this algorithm is being used for downstream machine learning, or you want to bring this into a data science platform and have your data scientists work with it, the queries that they get are going to be highly similar and just very close, if not in some cases even better than the real world data that was trained on. The second thing that we work to quantify is the privacy of the data. So in this case, we look at the process that was used to quantify the privacy benefit you get. So you get, once again, you get a score that goes anywhere from privacy protection of low all the way up to excellent. And excellent would be, you would have differential privacy turned on. You would have privacy filters that are removing records that are too similar, or that might be outliers that could be potentially identifying, overfitting protection and other things like that we built in to give you a good sense of confidence that, maximize the synthetic quality score and follow the best process for affecting the privacy of your data that you can.
Yeah, there's another question, actually, it's quite interesting, which is, what if I don't have enough data to train on? And I think this actually touches on a much bigger topic, which is, Alex, John, this is, I think, it hits core for us, because I know this is a big topic of roadmap for us, especially for this year, which is not necessarily just training on data, but what if I want to just be able to provide an ideal schema and say, hey, I just want to be able to generate realistic data from this particular schema and be able to train models on it. And I know one of the topics that we've talked a lot about, which I would love your feedback on, is, synthetics just doesn't have to be training on your data to boost, sort of unlimited amounts of data. It could be about the fact that there's the subset of your data that you need more on. And we've talked a lot about this and written about it around seeding, or potentially not having enough data. And I think that not having enough data is another angle to this, which is not necessarily the technology or the product component of synthetics, but is the economics of it, right? Like, I think one of the big things we've realized talking to a lot of our customers and users is, for some companies, you have infrastructure and a flow and a workflow that supports collection of massive amounts of data, making it usable, sort of putting it through a particular paces, and eventually sort of having an output from it that can be fueling various teams and resources. But for a lot of companies, especially if you're smaller, getting started, new BUs emerging into new sectors, setting up that infrastructure and that framework where you're collecting enormous amount of data so you can power analytics, just data workflows, or ML or AI, is sometimes economically not feasible, or is just not the right return on investment. So we know that one of the things that we've talked a lot about is synthetics is actually a business and an economic advantage compared to some of the traditional models. But we'd love to hear what you guys think about that particular question. One being, what if I don't have enough data? And then the general aspect, what if I don't have any data at all?
We see this all the time among our customers, right? Where you have either a couple records. And I think what you were calling out, Ali, is like, sometimes you are starting with an idea and you want to build a new feature and you have no data. Imagine you want to build a new product, a fitness tracker, right? But you don't have user location data, you don't have heartbeat data, you don't have the type of stuff that you would need to do this. The traditional approaches, creating a mock data set or fake data that I think, that could be done using like a Python program like Faker, for example, doesn't have realistic patterns in the data. So if you were to create a set of locations for users across San Diego, for example, right, using a library like Faker, for example, the results you would get would be a box of randomly distributed, little dots for where users would be. Some of them would be in the ocean, some of them would be on top of roadways and things like that. It just doesn't make sense and doesn't tell the story you want. I think one of the powerful things that I wish I could invite a couple of people from our applied science team to talk to this right now. But one of the really powerful things that we're looking at is what happens when these synthetic models, the same ones that are, this audience is using in our APIs every day, are trained on massive amounts of public data. And they can use that to create realistic user locations, for example. Or if you're running a fitness tracker, like what does a heartbeat pattern look like? And, kind of this vision that some of our customers are asking for right now that we're actively working on, where, what if you could compose your own types of data sets to mock out or to experiment with a idea where you don't have a real data set yet. So super excited about that.
John, anything you want to add there?
No, it was a good summary. I think the cold start problem was actually something we actually backed into when we got started. And so yeah. I think it's important to note like that ability to kind of generate synthetic data that is based off of some real world learnings is substantially more valuable than, let's say, just generating arbitrary mock or fake data through some type of generator that doesn't necessarily enforce any type of real world statistical properties.
Yeah, and I think this sort of goes back to the core of why the community engagement is very important for us, and we would love any feedback. As we're putting a link to our community channel, so if folks have any follow-on questions or comments or inputs, we would love to hear them, even if it's things you would like to see in our open source or product. But the main thinking here is that we all understand it. Needs for data is not going to go away. So our core mission is how do we make that data as available as possible and as safe as possible. This is also why, as you've seen in our product, we've ventured beyond sort of tabular time series data all the way now into image, and we plan to expand that even further, which is not having synthetic data in each particular vertical, but how do I create image synthetic data, combine it with tabular data, and actually make still accurate predictions in those combinations going forward. So this sort of being a big part of it, one of the questions Alex, I ended up seeing that came in earlier, and John, is how can synthetics be as good or not degrading my overall experience compared to raw data? And I know we actually have done a little bit of work with this. This was the work we ended up doing with University of California, Irvine, and a couple of other pieces where we demonstrated that synthetic data can not only be as good as raw data, but in some cases can actually be better. And in training models, actually, sometimes it can yield even better results for your ML AI models. And a lot of that actually has to do with the notion of a toolkit approach. But Alex or John, do you guys want to touch on that a little bit about how we think about that particular area of synthetics as good, so you don't have a, sort of a degradation in your overall experience?
Yeah, well, this is something that I would say we obsess on. So our customers hopefully in the future won't have to worry about this as much, right? How do you generate the highest quality data the first time? Our team has published, we did a blog post, I believe it was talking about our privacy filters and machine learning accuracy. We took the top 8 or 10 data sets on Kaggle that we saw that were being used for different machine learning tasks, and just said, okay, using Gretel default parameters, go ahead and create another data set, and we're going to measure the accuracy of this data set. So I like to use that kind of as a high level measure. I think across those data sets, we saw less than 3% degradation in accuracy when you completely substitute real world data for synthetic data. So that was really encouraging. Obviously, mileage may vary based on your use case and things like that, but across these really popular classification tasks and things like that we see and on Kaggle and other online data science platforms, the accuracy is very close. With some level of tuning or augmentation, so making that real world data set a little bit better, we often see the ability to improve. So one of the things that you might do is you might notice that there is a class in your data, minority class, that perhaps the algorithm you're training it on, whether you're using like XGBoost or something like that for classification, might not be as focused on optimizing. And perhaps for fairness reasons, perhaps for just trying to get the best accuracy possible, one of the things that you can do is augment those like, barely represented examples. Super popular in the fraud or cybersecurity world, where you only have a few examples of kind of known bad activity, but create additional samples based on variations from the larger data set. And that will help a machine learning algorithm generalize better against things it hasn't seen. At least it has the potential to do that. So super exciting. We're going to do a talk on this in NVIDIA's GTC conference in about 2 weeks. So we'll include a link for that one, not to steal too much thunder from that thing, but there's some pretty encouraging results that we've had.
All right, well, I know we're up on time. We have 1 minute left. We have one more question in the chat. Alex, John, I don't know if you've had a chance to take a look at it. Maybe we can have a 30-second answer to that, and then we can wrap up. And if there are any other follow-up questions, comments, or anything you'd like for us to get into a deeper dive on, please feel free to jump on our community Slack channel, and we're happy to engage. We have a much larger team there that can also get into the weeds if you have any particular technical questions as well.
I'm taking a look at Eric's question in the chat panel right here. Just for those that are streaming and can't see the text here, I'll read it out. So I was trying to demographically, statistically create comparable data sets using data commons and Faker. The intention is to mimic existing demographics for observations in certain areas. Feels complicated, and I haven't found a data set that works well for that. Difficult question. What you're trying to do is create a synthetic or fake data set that has realistic activity inherent as well. And it looks like there might be a location component to it. What we've found here is starting with a data set that's similar but applicable is a good place to start. So sometimes even that can be difficult. But for example, if you're looking for location data, we did a blog generating realistic location data based off these public feeds of e-bikes or scooters that the Ubers and the Jump bikes of the world, they have to share with the municipalities they're running in. So that's a great place to start if you can find something similar and essentially ask a synthetic model to recreate those patterns in your new data set. But what you call that, Eric, is one of the more difficult challenges, right? How do you find that initial realistic data to train on?
Okay, well, everyone, thank you for joining today. Really appreciate your time. I know it's always very difficult these days to take half an hour out of our day, so thanks everybody for joining. Again, we would love the community's feedback, input, insights, feedback, or anything that you think is something we should be doing better. This is something that has been enormously helpful for us at Gretel. So thank you again. This is going to be one of many things that we're going to do going forward to engage with the community, and look forward to hearing from all of you soon. Have a good day.
Thank you. Bye.